Okay, let's go over these conic sections. They're a little bit more rigorous than what we've seen in the past. So for problem number 1, we have an ellipse. And they tell you the center is 5, -4. So if you plot 5, -4, 1, 2, 3, 4, 5, 1, 2, 3, 4. There's your center. And it says the ends of the major axis are 5, 2, which is right there. And we have 5, -10. And then we have the minor axis, we have 2, -4.
Sorry, the screen's really blurry. That might just be me, but
And we
it is
have
a little
8.
bit.
Which screen? This screen?
Yeah.
It's still blurry?
There you go.
Oh, wait, it was good for a second. Yeah, there it is.
Is it okay now?
Yeah, that's
Yeah.
good.
Okay. So, if you plot these points and draw your ellipse, you will see that your ellipse is elongated on the y-axis. Now, with an ellipse, your x and your y do not change spots, right? What could change spots is your a and b. So this could be a squared, this could be b squared, or it could be vice versa.
Don't you put the center in at the top?
Yep, we're gonna do that in a minute. I just want to talk about the general form. So, is this equation gonna be like that, or is it gonna be like this? How do you know?
Like that. Because
Which of the two is this?
the major axis is.
It's the second one, because A is your major axis, that is the axis that's longer. So in this problem, we're not going to use this one, we're going to use this one right here. Can you tell me what A is equal to?
25.
5.
Oh, a squared is 25.
6? Oh, I counted wrong.
Maybe. I count 5.
You count 5? 1, 2,
I
3,
count
36.
4,
That's
5,
6.
6. It's 6, right?
Yeah.
So A is 6.
Oh, wait.
So you're going to put 36 here, and B is going to be 3. You're going to put a 9 here. Now, what else are you going to put is your center, like you said. If the center is 5, -4, your actual equation would be x minus 5 squared, y plus 4 squared, over 36 equals 1. Now that is the equation of this ellipse. Had this have been turned the other way and have a horizontal major axis, these two numbers would have been switched, okay? So the bigger number goes under the axis that it's elongated on. Now the other question, we satisfied writing the equation of this, but now they want the coordinates of your fixed point. Your fixed points are always lying on the major axis. So we need to find that C value. Well, you learned that a squared minus b squared equals c squared. So you're going to take, this is your a squared, 36 minus 9, which is 27. C squared equals 27. And if you took the square root of that, you get plus or minus 3 root 3. That's how far that your fixed points are from your center. So now, if we want to figure out what the coordinates are, what can we do? We are going to add and subtract 3 root 3 from the center. But are we going to add and subtract it from the x value or the y value? It's moving vertically, so your fixed points are going to be 5, comma, -4, plus or minus 3 root 3. Now these are the coordinates of your fixed point. If you want to turn this into a decimal, then you would know exactly you're going over 5 and where is it going to be located, here and here. Okay? Now if your ellipse were elongated, you would have added and subtracted 3 root 3 from the x value, because remember, your c value is always along your major axis. So you got to figure out, are you adding and subtracting that from the x or the y value of your center? Does that make sense? Okay, so number 2. Number 2 talks about a hyperbola. And let's first graph the information that's given. This gives us a center of 3, -1. And a vertex of 3, +1. Well, so that means that I have a hyperbola that looks like a tree, or a Y, you guys called it. Now, with the hyperbolas, let's go over real quick what they look like, what the general forms are. First of all, it's x squared minus y squared, or y squared minus x squared. Now, what does not change spots is your a and your b value. The a value is always from the center to your vertex. Now, how do you know if it's an x squared problem or a y squared minus? Well, it's hugging the y-axis, so it's this one, not that one. If my a value was, if my vertex was somewhere like over here, and I was drawing it that way, this would be my a value, and I would have started with this orientation right here, x squared over a squared. So I know right now that my a value for sure is 2. So if I wanted to sketch the graph of this, I can go to the other way, because this is A, and A. This is called your transverse axis. Okay, transverse axis. Now, we don't know what B is yet, but we do know what the center is. We said the center is 3, -1. How do you incorporate, because this is a common mistake, how do you incorporate 3, -1 into our x and y correctly?
Y plus 1
Very good. Y plus 1 squared.
x minus 3.
Good. Be careful, because a lot of people will switch those around. Now, I know that my a value is 2, so what am I going to put under here? 4. Okay? Now, the other thing that they tell you is that we have this asymptote. 3y equals 2x minus 9. This is one of the 2 asymptotes. Now, let me review real quick with you guys. If we have a vertical orientation hyperbola, your asymptotes are going to be plus or minus a to b x. This is your a value, and your b value is your conjugate axis, okay? If it's up and down, it's plus or minus a to b. If it's sideways, if it's a horizontal, like that, your asymptotes are plus or minus b to a. Okay? Now, I also want to go over what happens when you are not, your center is not the origin. The only thing you have to know, you have to insert your HK. So all I want you to remember is remember y is your k value. it looks like that. That's what your asymptotes are gonna look like. So remember HK, just keep it together. Your H goes with your X and your K goes with your Y. So we didn't get to talk about this when the seniors were here. So if it's sideways, here is how you will write your asymptotes. It's the same orientation, but don't forget your HK. That's it. Okay? So keep in mind, here's one of our asymptotes. I need you to solve this for y. So we're going to subtract or divide by 3. So y is equal to 2/3 x minus 3. This is one of the two asymptotes. Now you can graph that. How do you graph y equals 2/3 x minus 3?
Why was that nice to think?
You begin at -3, and you're going to go up 2 and over 3. Up 2 and over 3. So there is one asymptote. Okay? Now, I want you to look at this. This is your A to B ratio. How do I know it's A to B? Because it's going up. Its orientation is vertical like that. So we're going to set this A to B ratio equals 2/3. And we already know one thing. What do we know? What do we know? Anybody? What's A? It's not 4, it's 2. A is 2. This is A squared. So we know A is 2. So what's B going to be? 3. So B is 3. Can you give me what number goes under here? 9. Because of this relationship, A to B, versus if it were on its side, it would be B to A. Okay? So up and down, A to B, sideways, B to A. Good so far? Okay, next, flip it over. Number 3. Number 3. This one is a parabola. Okay, what do they give us? They give us, it passes through the point 4, -5. We haven't seen one of these yet. This is going to be an XY on the parabola. Here's my vertex. I can plot that. -4, -3. 1, 2, 3, 4. 1, 2, 3. That's our vertex. So if this parabola is passing through 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And that's my vertex. What does this thing look like? It's shaped sideways. It's like this. Now they threw this in. Axis is y equals -3. That's not the directrix. That is your axis of symmetry. It's saying that your axis of symmetry is y equals -3. So what do you know about that axis of symmetry? Well, you know that you're going to have another point that's equally as far away as that is from the axis of symmetry as it is above. So here's a picture of your parabola. Okay? Now, can you tell me what were the two different orientations of parabolas? What were the two major, we had y squared equals 4 positive or negative, right?
You have to move it down.
Move it down. More?
You're good.
Okay, thank you. Or it could be x squared equals positive or -4, right? I'm not going to put that there, but those were the two major types of parabolas, right? So, which of the two is it? Is it a y squared problem or is it an x squared problem?
Y squared.
It's a y squared. Is the 4 a positive or should it be a negative?
Positive.
Okay, so we're gonna cross this one out. And you're right. Now, can you tell me how to put that, that vertex in correctly? Our vertex is -4, -3. What goes where?
Well, you can do 4 minus -4 squared, because, are we trying to find P right now?
No, right now we're
Oh.
putting the vertex in. Let's put the vertex in. Y.
So, yeah, y plus 3.
Plus 3 quantity squared equals 4. It's a positive 4, right?
Yeah.
And then x.
Or wait, yeah, plus 4. I keep looking at the wrong.
X plus
4.
4. Okay, good. Now, what do we not know at this point? We don't know P, but guess what we do have? We have a point. We have an X and a Y value. This is where we're going to plug 4 in for X and -5 in for Y. So we have -5 plus 3 quantity squared equals 4 times some P value, and then 4 plus 4. So help me out here. We have right here, 4 plus 4 is 8. And 8 times 4P isn't that 32P? Yes or no? This is -2. -2 squared is 4. How do you solve for P?
Divided by 32.
So 4 over 32, which is 1/8, is our P value. So now, guess what? We can figure out the rest of this problem. Can you tell me what the coordinate of the fixed point would be?
You have to move down.
Move it down. How would you find the coordinate of the fixed point? So if this vertex is -4, -3, I need to move in, our P value we found is 1/8. Can you name the coordinate of that fixed point? Where is it? It's somewhere right there. So you're gonna go 1/8 closer to the origin. So name the coordinate.
-3, so it's
-3 and 7/8, comma, -3. Okay? So you went 1/4 closer to the origin, but you still have to go down 3. So that's your focus point. Can you tell me what the directrix is gonna be?
x equals -4.
Mm-hmm. X equals -4 and 1/8. This is your directrix, and that's your focus. Okay, the next one, number 4.
Can you go back to the left real quick?
Oh, yes, I'm sorry. So put everything that you can into your problem, like your vertex, anything that you can. Start with your shell. That's what I do. Start with my shell. And then I plug in my vertex, and I look at what I have, and I plug that in to see what's left. So what we needed to find was that P value. Also, while we're here, how do you do the lattice rectum again? What is the lattice rectum? It's the length of that chord, and how long is it? It's 4 times this measurement. So the lattice rectum is 4 times 1/8, which is 1/2. So if you wanted to find the endpoints, you gotta cut that in half, so 1/4. You're gonna go 1/4 above this fixed point and 1/4 below, and you can give me the 2 endpoints of that parabola, of the lattice rectum. Okay, number 4. Can you identify what conic section this is? Well, we're gonna put it in standard form. Sam, am I in the camera still?
Kinda.
Ish.
Ish? No?
I'm just gonna scoot back.
Let's see. You can move the paper up more now.
Move it up, like that. Okay, so we want to write this in standard form. It's in general form right now. So the first thing I did was I grouped my x's together and my y's together. And I shipped my negative 11 to the other side, correct? Now, we have a problem. We want to complete the square, but I don't want this 32 here, or I'm sorry, the 4 here. So I'm going to pull 4 out of these two. So if I pull this 4 out, what's left? What's this? 8x plus something. Let's stop for a second. We want to complete the square here. So you're going to take half of this and square it. What do you get? 16. So I added 16 here. Not really. I added 64. I added 64 here. Does everyone understand that? So I have to add 64 to the other side. Now this piece right here, you're going to pull 25 out. Okay? Half of that and square it. You're going to add 1 here. But really I added 25. So now let's factor this. We have 4 times x plus 4 quantity squared plus 25 times y minus 1 quantity squared. And if you add these 3 numbers, you get 100. Okay, now what's wrong with this? You have to equal 1. So this is the boss now. We're going to divide everything by 100. So you're going to do 100 divided by 4, which is and 100 divided by 25, which is 4. Now you can tell me everything about this problem. You can tell me the center. Where is the center? -4, 1. And you can find the A value. A is 5 and B is 2. And you can finish graphing this. Okay? We'll finish this tomorrow.
We're gonna use this.